Well, thank you everybody for joining us today for another one of the Siemens webinar topics. Today we're going to delve into the world of standard cycles and explore from the ShopMill perspective. I am going to be your host today, Chris Pollock. I am the manager of the Virtual Technical Application Center, so I get to create a lot of the cool online content you see. But I will be joined by a colleague today that's going to be the presenter, but I don't want to spoil it yet. So we'll announce him in just a second. But prior to that, I did want to just go through a couple things. Certainly, I never want to pass up the opportunity to plug some of the up and coming events we have going on. So keep an eye out for that. We're going to have an additional guest presenter in June, Lars Fowler, and Lars is doing a case study on 3-axis technology versus 5-axis. So specifically methodizing a job, what are the pros and cons, where are the advantage to moving into 5-axis on a standard 3-axis style job, so something you could traditionally do on a 3-axis mill, to try to explore its benefits. But there are areas where there's going to be some costs, so we want to kind of create a case study around that. And then after that, in June, Daniel Vitullo is going to come back and he's going to explore the world of ISO programming specific to turning. So it's a hidden little gem or hidden little secret in our control. A lot of people don't realize that if your control has turned it on or the OEM enabled it, we can run standard ISO programs on the Siemens control. And when I mean ISO, I mean a FANUC-based program. So if it's something that you're interested in, I would strongly suggest coming back and checking that one out. That's June 24th. Additionally, you want to keep an eye on our CNC4U website. Certainly, this is where all of our webinars end up being posted, as well as promoting some of the new ones. If you're not on our contact list, I would certainly suggest getting on our contact list as well. This way you'll get notifications on up and coming webinars. And we do also have an additional resource that's pretty handy called our Content Manager. So we've been doing this for quite a few years now, and as with anything, we start to build a lot of material. It gets hard to kind of navigate and figure out what you're looking for, what you need. So if you go to our CNC4U website, if you go to the training section and then click on virtual training, there's a link where you can download this content manager. And what the content manager does is it has all of the videos we've produced, some of the stuff that our colleagues have produced over the pond, and certainly all the stuff we've done here domestically. And it even is a smart document. So you can just click on those couple of questions up at the top, and then we'll highlight the recommended videos and content that you should check out on those topics. So certainly take advantage of that. Additionally, we do offer in-person training. Unfortunately, not right now, obviously in lieu of what's been going on, but we will be restarting those classes up once things start to go back to normal. What I will say though, is a lot of this content we're starting to transition over to online. So if you're interested in getting involved in some multi-day training, more one-on-one with an instructor, keep an eye out. We have a class that we're going to be actually sending out the email promotion for it on Monday that you can register for, and it's a instructor-led in-person class, but it would be virtual, so it's online. So check that out. Also, don't forget to look at our Mr. CNC YouTube channel. We're doing a lot of unique stuff there, as well as our whole series of YouTube Live. I will be doing a YouTube Live event on the topic of interpolation turning coming up next week, next Thursday. So that's another one you want to kind of check out. So if you go to the Mr. CNC channel, you will see that being promoted there, and you can, I even activate a reminder for you if it's something you're interested in. While we've been in this whole new climate and environment of this COVID pandemic, we did launch a new resource we're calling our Virtual Product Expert Program, managed by Daniel Vitullo. So if you're interested in booking some one-on-one time with a product expert, we can do that as well. So I would say if you'd like to delve into the SINUMERIK control world a little more, and you want to do it more on a one-to-one basis virtually, we do hour segments. They're managed through Danny Vitullo. He either hosts them himself or he'll get other colleagues like myself involved to work with you guys, but this is a great resource for you guys to kind of get into a deeper level of questions and functionalities. So certainly take advantage of that. But without further ado, I'd like to introduce you to our presenter today, Steve Holmes. And I see Steve is observing social distancing. Shall we say hello to Steve? Hi, how you doing, Steve?
I'm doing fine. I hope everyone else is doing well.
I'm sure we are. I love the picture. It's great. I think it's probably appropriate. We're certainly within the 6-foot social distancing restrictions, so I certainly appreciate that.
Yeah, I thought that it can't be too safe these days. I did hear or read the other day where the virus can be transmitted just by speaking. So I just didn't want to take any chances there. But actually, I'm probably one of the few people out there that likes wearing a mask.
Really?
Oh yeah, the way that I look at it, the more of my face I can hide, that's probably not a bad thing.
Well, there you go.
Anyways,
So Steve's been with us. Boy, I think it's going on 6 years now, Steve. Uh,
yeah, it's time flies when you're having fun.
It does, it does. So for those of you that may not know Steve, Steve is my colleague and counterpart on the West Coast. So Steve has the luxury of living just south of LA and sunny California. I never feel bad for him when he's telling me how nice the weather is outside. But Steve comes to us with a wealth of knowledge, been in the industry for quite a long time, well over 30 years, knows a lot of technical applications, certainly a product expert for Siemens, as well as a lot of other legacy controls, shall I say. But Steve has decided to step up and help me out with the webinar program. So Steve is going to be presenting our topic today. So with that being said, I am going to switch over to you, Steve. So I just have to stop sharing for 1 second. This is always a little clunky. And then we're going to make you presenter. All right, so you are now presenter, Steve. So you should be able to share your screen.
All right, so
And there you are. Look at that.
I trust everybody can see that. Um,
Looks
Thank you,
perfect.
Chris, for that introduction. Of course, I'm not sure why I'm thanking you. I wrote it, but
Well, I ad-libbed it a little
yeah,
bit.
yeah, you did. Thank you for that. But one thing I never do, I only mention the weather in California to Chris during the wintertime. In the summer, when it's 100 degrees out, I just kind of leave that alone. But
And
I
that is
always
that is true.
take advantage of the opportunity to rub it in a little bit. But to get right at it, today we'll be talking about standard cycles with ShopMill. So everything that we'll be discussing today applies to both the 828 and the 840 as far as Sinotrain is concerned, and as far as the basic cycles are concerned. There really is no difference. So everything that we go over will apply to either control. So our primary topics will be drilling cycles. We'll explore some different types of drilling cycles along with some milling cycles, and also the different ways to describe the positions for the drilling cycles. And then we'll actually be transitioning back and forth from this PowerPoint to live demonstration on Sinutrain. So let me move it along here. So this is the part that we'll be exploring today. And the first thing that we're going to do is face mill the whole surface, and then we'll move to a circular pocket to do this 2-inch diameter pocket here in the middle, and then we'll be doing this raised boss surface known as a spigot in the Siemens control. So really, a spigot is nothing more than just a raised boss or a raised island. So we'll be doing that, and we'll be doing this open slot, and then we'll go through and we'll center drill all 6 holes. And what's kind of interesting about that is they'll be on different planes. So we'll use the center drill functionality on different planes, and then we'll go to drilling those same holes and tapping those holes. And time permitted, maybe we'll throw a little engraving in there as well. So we're going to start by using the milling cycles. And the way that this works on the control is when you get into the machine, you'll see this horizontal row of soft keys. So we'll be selecting milling. And then on the right side of the control screen, you'll have your choices of all these different types of standard milling cycles that are available on the control. So the first thing that we'll be doing, as I said earlier, would be the face milling. And then we'll do some pocket milling. And then go to the multi-edge spigot where we have different choices. We can either do a rectangular spigot, a circular spigot, or a multi-edge spigot. And then there is the slot milling cycle, and we'll also have 3 different choices as far as slot milling. And then there's engraving, thread milling, and then again, engraving. So the first cycle that we'll be exploring is the face milling cycle. So whenever we select face milling, this is the screen that we'll see. And it's real similar to no matter what cycle you're in, this screen is going to look very similar. The input mask or the fields will be different, obviously, depending on what type of cycle you're in. But it's just a matter of going through this list from top to bottom and answering these questions. In addition, in the face milling cycle, you also have these modifiers on the right-hand side. So this gives us some extra flexibility as far as protecting edges, whether it be you wanted to maintain a wall, or maybe you have some clamping on 1 or 2 sides, or wherever. So the other thing on the right side of the screen here, this is an example of the context sensitive help menu. And that's addressed by just pressing the help key. When you see these navigational keys on the right side of the screen, you'll see a help screen. On your actual control on the machine, it may be located a little differently as far as where it's placed on the panel. But on SINUMERIK, it's right next to the navigational keys. And the nice thing about it is it's context sensitive. So whatever cycle you're in, you press help, and then you get this helpful little text to help you move along, answer some questions. So next we'll be doing is applying this face milling cycle to our part that I was showing earlier. So the first thing that happens when you go into a cycle, start a program, you'll get this header. So we'll be answering some basic questions, setting setting what we're going to use for the entire program. And then we'll be selecting milling, and then face milling, and then there's the face milling cycle. So we'll start by using a 2-inch face mill. So with that, what I'd like to do is transition right to SINUMERIK. And this is the Siemens offline control emulator. It really is a useful tool, a helpful tool, not only for just training, but programming parts and checking parts, checking for collisions and things like that. And that can be downloaded free of charge for the basic version right from our the CNC4U website. And Chris, am I right? And there's several different versions available, whether it be software version 4.5, 4.7, or 4.8. I think that all those versions are still available on the CNC4U website.
Yeah, that is correct. And the reason why we do that is you do want to try to observe compatibility between your machine tool and the offline software, specifically when you're programming conversationally. So, if I write a program in 4.7, let's say, in conversational, it won't necessarily run in a 4 or 5 machine. So you always want to make sure you keep that compatible. 4.7, 4.8 are basically identical, so you don't run into it quite as often. But that's why we have the versions for sure.
Great point, Chris. Thanks for bringing that up. The software version that we're looking at now is 4.8 Service Pack 2. So whether you have software version 4.7 or 4.8 on your machine, they're virtually identical. There are some behind the scenes advancements in 4.8 that you don't see in 4.7. And same thing with version 4.5. The screen might look a little differently. You're not going to have the widescreen format, but basically everything that we'll be doing, most everything we'll be doing, will apply almost directly to versions 4.5, 4.7, or 4.8. If there are some little discrepancies between the versions, I'll try to point those out as we move along. So the first thing that we're going to do is we're going to go to the program manager and we're going to create a program. So that's located right here above these navigational keys. So select program manager. And then if I go to part programs and select new, I can now give it a program name. So it's important to pay attention always to what's on the right side of the screen. Right now it's coming up in ShopMill, but if you're just opening up a machine for the first time, it's going to default to program guide, and that's a different, slightly different interface as far as programming is concerned, because it's going to be G-code instead of conversational. ShopMill, of course, is strictly conversational. So I'm going to give it a name. I'm going to call it example _1. So letters, numbers, and underscores, those are the only characters that are accepted in the program name. So from there I will select OK. All right, and that gets us right into the header. So these are where we'll be establishing what's going to be consistent throughout the entire program. So first is the unit of measurement. So your inch or metric, everything that we're doing is in inch. Let me bring up this part here. So this is the part again that we'll be doing. Everything is an inch. We'll be using G54 as our offset. If we wanted to change it, we can do that right here in the header. And then we also have the choice to describe the stock that we'll be machining, and this is strictly for simulation purposes. But we have block centered. If we were doing a cylinder, we could select that. We could do a pipe. Block centered is what we'll use, but if we want to describe it by a block, we can do that. And we'll notice whenever we change fields that our graphics change as well. So that's kind of a nice feature in SINUTrain in the help menus. But we will be using a block centered, and our material is 5 inches by 5 inches. Let me just bring that up full screen for a minute. So 5 inches by 5 inches and 1 inch thick. So 5 by 5. Now the top of the part is that our initial dimension is not going to be part 0. This is going to be the material that we're going to leave for when we do a face mill. So we're going to leave 25 thousandths. We're going to start with 25 thousandths as our initial dimension, and our thickness of the block or our material is 1 inch. And this is an absolute value. Whenever you select an absolute value, you do have to provide the negative dimension, if in fact that's what you're looking for. So the plane is going to be G17. We're not going to be using G18 or G19. We'll stick with G17. And the retraction plane, so that's how far the tool comes up above the surface of the part before it transitions to the next location. So we're going to stick with 1 inch, and we want to have it at, in this case, more than a half an inch, because that's the height of our boss here. So we want to make sure we don't have any collisions when we're moving from location to location. So we'll stick with 1 inch, the safety clearance. So that's the point where the tool is going to wrap it to before it feeds down into the part. And we're going to use 100 thousandths for that value. Now the machining sense, or the direction of the cut, we have the choice of down cut or up cut. So down cut is an actual climb mill or G41, and up cut would be a conventional mill. Okay, so we will select down cut, and then the retract position pattern, we have the choice to go all the way up to our retract plane, or we can optimize it. So if we have multiple raised surfaces or clamps, things like that that we want to avoid, we can select the optimizer, and the control automatically calculate how far up it needs to go in order to avoid those collisions. So we'll stick with retraction plane, and we'll set escape. And from there, our first operation is going to be the milling, the face milling. So this is the horizontal row of soft keys where we'll make a decision on what it is that we want to do. In this case, we will be milling. And then when we select milling, here's our vertical soft keys. And we have the choice for face milling, which is what we'll be using. And from here, we'll want to select a tool. I have a face milling tool in there, but I'm going to go ahead and select another one just to go over the mechanism, at least at the beginning. So if you guys haven't seen it before, this is how we would create the tool. So you do have to go to any empty location on the tool list. And then from there, select new tool, and then go to facing tool and hit OK. And then we'll call this one, say it's a 2-inch tool. And what's kind of unique about the facing tool is once we select it, let me put in the length and the diameter of 2 inches. So with a facing tool, I'm also going to give it the number of teeth. So this is the amount of inserts that are on that tool. In this case, we'll go with 5. But we also have this further data key. And with that, we can provide the true outside diameter. Because of the shape of a typical face mill, the actual outside diameter might be larger than what it's using to cut with. So we'll use 2.25, and then we'll have an angle of the inserts of 45 degrees. So we select that, and we go back, and now that tool is, we've provided the values for that tool, we go to program, and then it puts that tool in there. It does default to D1 if you're first creating a tool, and what the D value is those are the multiple edges for that tool. You can have up to 9. This tool, we're just using 1. And then when we go to the feed rate, we have our choice of inches per minute or inches per tooth. And we'll go ahead and use inches per tooth because remember in the tool page we did provide that information. And then the control will calculate the surface feet per minute based on the RPM. It does those calculations for us, so that's kind of nice. And then when we get to machining, you have the single diamond selection, or you have the triple diamond. So single diamond would be for roughing, and triple diming would be for finishing. So we're going to rough it, and then we can then select our cutting strategy. So we have here we have a Y step over in a unidirectional cut. If we were doing a bidirectional cut, you can see it rapids back. And then if we wanted to do this step over in the X direction, either bidirectional or unidirectional, we have all those choices. So we'll select the bidirectional. And here's another thing that's kind of nice about SINUTrain. When we go into face milling, it automatically populates these fields with what the information that we put in from our header, because we had told it that we had a 5-inch square. So it calculates the lower left-hand corner, x minus 2.5, y minus 2.5. The height of the blank, 25 thousandths, and then the incremental distance from the lower left-hand corner, either in the X or the Y. So the control calculates that for us automatically. The final dimension would be Z0. And then the step over, the DXY, can be defined either in by percentage or an inch. I have a tendency to use percentage because it just saves me a little bit from doing the math of figuring out the diameter of the cutter and what is 50-60% of that diameter. So this does it for me. And also, as I change tools, maybe I select a tool that has a different diameter, then I don't have to worry about changing this field. So the DZ is the maximum in feed, and the way that works, as long as this value for the infeed is greater than or equal to the Z0, it'll take it in all of that pass. This doesn't mean it's going to go deeper. It will not. It'll just go to the 25 thousandths. It's going to take it in one pass. If I had put in, let's say, a smaller value than 25 thousandths, then it's going to kind of calculate what it needs, and in that way you can kind of set up your own finish pass without having to go into the triple diamond for the finish. But we'll just be roughing it. We'll be doing it all in one pass. And we're also going to maybe turn on a couple of these are the modifiers that I spoke about a little earlier. So you can select any one or all of the four corners. If you get to one that it can't do because of the strategy that you selected, it won't allow you to do that. It'll give you this message down at the bottom, and it'll say you can't do that. But we're going to leave a couple of these modifiers on there, and we'll sit, at least for now, we'll accept that. And now we can actually go to simulation, because we have enough here where we can simulate. Okay, so you can see it left the wall there, and if we go to the 3D view, we can see that it left the material there to protect a collision from the side wall from this 2 1/4 inch tool that we're using, but actually the cutting surface here is only 2 inches. So that's kind of nice. The control calculates that for us. So I'm going to go back to my cycle. Let's see, and then I'm just going to go ahead and turn these modifiers off. Hold on just a minute. Delete. Put an extra cycle in there accidentally. Don't want that. Okay, turn these modifiers off. Accept that. Simulate it. And then there's our part. We can go to details and zoom it, rotate it. Or if you're on SINUTrain, or if the machine has a mouse or some type of mouse control, you can use your mouse to do the same thing. So from there, I would like to transition back to my PowerPoint. The next thing that we'll be exploring will be our pocket cycles. So when we select pocket, we'll have the choice of a rectangular pocket, where once again, all we do is we go from top to bottom and fill in these fields. These are really just questions that that we're answering, given the values that are in our print. And then the circular pocket is another choice that we have. So we will then be applying these cycles to our part. So we're going to first select milling, then pocket, and then circular pocket, and that's going to bring up these fields. And for this example, we'll be using a 3/4 inch end mill. So back to SINUMERIK. So again, this is what I'll be doing, right? And this is how I'll be doing it. So this is the what on the horizontal soft keys, and the vertical keys would be how. So select milling, and if I go to pocket, I have the two choices. I have a rectangular pocket, which we'll not be using, but we'll just talk about it a little bit here. The first thing that you see is this input mask, or this input field. And in versions 4.7 and 4.8, they've added either the complete or the simple input. So simple kind of reduces the amount of fields that have to be filled in order to complete this cycle. So you lose a couple, like you lose the ability to, in this case, define the center point of the pocket by anything more than, or not the center point, but the reference point by anything more than the center point. In other words, if you have the complete field, you can do lower left, lower right, upper left, upper right. So you have all those other choices that you lose when you go to the simple field. And there are other values that change too, and we'll get to those as we move on down the list. So this is where we would put in a tool from the select tool vertical soft key. The feed rate, again, inches per minute or inches per tooth, spindle speed, reference point. And then when we get to pockets, we have a couple more choices as far as machining. We not only have the roughing and the finishing, you also now have the ability to machine the wall of the pocket. And in just a few seconds, we'll see the animation, the animated elements kick in, and there it goes. So it kind of gives you a visual representation of what that tool is expected to do. So that's another nice feature. You can also put in a chamfer. So if we wanted to just do a chamfer on that pocket, we would select that. And then when it comes to the next field, and it's either single position, in other words, do we want to do that pocket at just one location, or do we want to do it at multiple locations? So we can define those locations as with a position pattern, and we'll be doing that a little later on. But this is another one of those fields. When you go to simple, you lose that ability to put in a choice there. Now, it's also important to note in software version 4.5, you still have this functionality available. It's just located differently than it's through other drop down menus. But we're going to stick with complete. And then, of course, the center point of the pocket in X and Y, the top of the part or the top of the pocket might not be the top of the part. And then the pocket width, the pocket length, the radius for the corner of the pocket. And then if we wanted to clock this pocket at any given angle, that's where we would put that value in. And that's another field that you lose when you go to the simple input field. Now, we're happens to be in chamfer right now. And once you select chamfer, you do have to provide some extra information about chamfering. So you need to give it the FS, which is the width of the chamfer, and the ZFS, which is the depth of that. And those values are really relative to the angle of the tool that you're using and the type of the tool. And we'll play around with that a little bit more as we move along. So I'm going to cancel this because I'm actually not going to do a rectangular pocket. I'm going to do a circular pocket. We put the print back up there. Okay, so the complete input mask and the cutter, I've already pre-populated this with well, actually, I think in this example, we'll change it to, or do we have a 3/8 cutter? That's fine. Feed rate 30 inches a minute. We'll stick with that, 1500 RPMs. And we're going to be doing just the roughing pass. And then we also have the choice now of how do we want that tool to enter into the part. So do we want to use a helical interpolation in order to get to that? Or do we want to use a centric? So if we're using a center cutting end mill, or maybe we had pre-drilled a hole, we might select centric, but in our choice we'll do helical. And here where it says position pattern, we want to make sure that we select single position, because we're just doing this particular pocket at one location in the center of the part. X0, Y0, Z0 at the top of the part, and the radius of the pocket is, I'm sorry, the diameter of the pocket is going to be 2 inches. And the depth of the pocket is, we're going to go all the way through. So we're going to put maybe 1 inch. If we keep this as an incremental value, then we don't need to provide the sign. If we were to change this to absolute, we would need to provide the sign because it generates this message. Endpoint has incorrect definition. This is telling us that this is incorrect. So we'll stick with incremental here. And I'm using the mouse to toggle. It's kind of important to know if you're on the machine, you don't have the mouse, you use this select key, it does the same thing. You do have to be careful that you don't have number lock turned on, because if you have number lock turned on and you select the select key, you get the number 5. So if anybody has experienced that, that would be the reason why. So we'll turn number lock off, toggle to incremental, and leave that at 1 inch. If we wanted to program this as a negative value, we certainly could. Even an incremental doesn't hurt. The step over are DXY, and these definitions remain consistent throughout all the cycles. So anytime you're in DXY, you're looking at the step over in X and Y, in this case 65%. I can put it in as a decimal or a percentage, and the pitch of the helix, we're going to have it at 0.125. So every revolution around the part is going to step down 1.25 or 1/8 of an inch. We're not going to leave any material for a finish pass, and the X, Y, or the Z. And the last field we have to, the last question that we need to answer is the material we will be removing. Will it be complete machining, or will it be remachining? So remachining might be if you had an island there that you wanted to protect, or maybe it was a pre-drilled hole and you just didn't want to spend the time to cut air. So that's where remachining comes in, and then you then supply a couple more parameters for that. So we will go to complete machining and select accept, and we'll take a look in simulation graphics and see how that looks. So we can control the speed by these override keys here, and that's displayed here in the lower right hand corner. Right now it's at 55%. We can speed it up, we can go to 100, or if you have a keyboard, you can do Control M, and then that automatically toggles it back up to 120%. And if you do Control M again, then it goes back to wherever the last override percentage was set at. Okay. So that's our circular pocket in the middle of the parts. From there, we are going to go transition back to the PowerPoint. Next slide. Okay, so then the next operation that we're going to perform is the multi-edge spigot. So again, a spigot is what's more commonly referred to as a boss in this country. It also sometimes is called maybe a raised island. But as far as on the Siemens control is concerned, in the Siemens world, it's going to be called a spigot. So we have three choices. We have the rectangular spigot, where again, we'll just be answering these questions, these fields one at a time from top to bottom. So anytime we have a rectangle, we're just going to provide that information. And then the circular spigot would be the next choice. And then what we'll be using in our example is the actual multi-edge spigot, and this one gives us a little bit more versatility because it gives us this dxy value. So that gives us the ability to step over in the x and y axis to kind of rough that part out. And then to apply this to our example part, we will first select milling, multi-edge spigot, multi-edge, answer these questions top to bottom. And then in this example, we'll be using an 1 1/4 inch end mill. So with that, transition back to SINUTrain and go to milling, cancel out of there. Okay, so multi-edge spigot, so we select that. And then our choices would be the rectangular spigot, and we can notice there is no DXY, so there's no XY step over. The control is just going to take it all in one pass. So if we had material that we wanted to rough out, we would just simply add another cycle on top of this one to get to our finished size. So all these values are the same. What's different with the rectangular or with the spigot cycles is you have your the size of your the initial size, and then when you get to your what you want to machine to, you have the length one and the width one. So that would be the size of your boss. You also put in the same thing like the other cycles, the radius on the corners, whether you want to clock it, and then some finish information. So there's the rectangular spigot, there's the circular spigot. Again, no DXY, no step over in the X or the Y axis. But when you get to multi-edge spigot, this is where you get a DXY value. So let me change this to roughing, and we're obviously going to want to change this tool. So we're going to use a 1 1/8 inch cutter. Load it in there, 30 inches a minute, 2,500 RPMs. Let's slow that down a little bit. So machining, we have the same choices. We have the roughing, finishing, the wall, the chamfer, single position or position pattern. We'll stick with single position. Center of our part is our XY0. Top of the part in Z. The diameter, this is a number that you can kind of play around with to see how the roughing is going to work. So let's start with a 4.5. We have 6 sides. The distance between the flats is 4 inches. We're not going to clock it at an angle. The corner radius, as defined by the print, is a 1/4 inch. And the depth related to Z0 is a 1/2 inch. If we can see that down there on the part. And then this is the DXY. So this is the value that it's going to step in each time for each pass. So we can do multiple passes now by just using this one cycle. And what's kind of nice too, even you can use a multi-edge spigot if you wanted to do a square, you can use this same cycle for that, just by making the length and the width having 4 sides and having them equal, or even with a circular spigot, if you had the width equal to the diameter of the spigot, you could use this cycle for that, and then that gives you this dxy field, this percentage for roughing in, so you don't have to go through and set up another cycle. So DZ, this is how much it's going to take in each pass, and we'll do this in 2 passes, and then we're going to leave 25 thousandths for the finish allowance in X and 10 thousandths in Y. So we will accept that. Go to simulation. Maybe speed it up a bit. Also in simulation, I can, if I go to this key here, I can turn off the tool path. I can show it, I can delete it, so it'll show it from that point on. Kind of clears it up. So we can see we kind of left these corners here. So we'll go back to edit, go to multi-edge, and then we'll change this to a 5.5. That should clean up those corners. We'll accept that. And now we'll go ahead and we'll do our finish pass. So we did a roughing pass, single diamond. So I'll be going milling, multi-edge spigot, change this value to finish, and then keep these values. We're going to leave 25,000. Actually, we're not leaving this material here. These are the values from the other cycle. Now, what happens a lot of times is the programmer will set that to 0, thinking that needs to be their finished size. Well, really, if you set this to 0, what happens is you get this error message, that finish allowance due to rapid traverse positioning. So, and then it kind of highlights that in red, telling you there's an error, and it doesn't allow you to accept it. So you have to fix it before you can go on. And the reason why it does that is because this is actually the step over. You don't want it rapiding right into the side of the part. So this is actually the ramp that it uses. So I'm going to put this at 0.025. And if you just leave it here, it's going to finish this part down to the finished dimension. So it's not going to leave this material because we're in the finished pass, and it knows enough that this is where it's going to go to the finished size. So we will accept that. Before we do that, maybe we'll change the Z to 1 inch. No, I'm sorry, half an inch. Accept that.
Looking good, Steve.
Yeah, so when it does this simulation, this is where we need some actual like bumper music or something to kind of fill the
yeah, a little background
time. Yeah.
I did want to let you know we're just about 10 minutes to the hour. Just keep you on track here. But we're moving along nicely for sure. I see some questions coming in. Certainly, those in the audience, feel free to jump into the Q&A panel or the chat panel and toss in your questions. We will do a Q&A panel at the end, but if I can find a spot, maybe we can even throw some in as we're going. But so far, so good. Everything's looking great.
All right. So we'll go back to edit, and the last thing I wanted to do is, even though it's not shown on the print, I'm going to go ahead and put a chamfer around the edge of this spigot. So I'm going to go milling, multi-edge spigot. So it automatically comes where I was at the last time. Now I'm going to select chamfer. So this is where it populates all the same information. The only thing I've changed is chamfer, and then the only other thing I need to change in here is I want to make sure that my ZFS, right? That's the FS is the width of the chamfer. In this case, I have 32 thousandths, and the and the ZFS. So if I was to change this value to say 32 thousandths, and if I go to simulate it, let me accept it first. It tells me that that's not possible because the insertion depth is too small. And I believe the reason that it does that, and correct me if I'm wrong, Chris, is that's because of the angle of the tool, right? If it can't physically do that, the control does the math. So you have to have enough of a step down in order to get that to work
That's
correctly.
exactly correct. We have to have enough surface area or geometry on that tool to be able to machine it properly, for sure.
All right. But one thing I don't want to do for sure is I don't want to use an inch and a quarter-inch cutter to do a chamfer. Not the
That
same.
would be problematic.
Might be a problem. So from there, let's say I select countersink. I hit OK. That loads it in there, and hit accept. Simulate. Speed it up a bit. And we can see it cleared all the way around the, took off those edges. Finish pass. And there's our chamfer. So you can see how easy it is just to add something like a chamfer to a part or to a cycle that's already been pre-programmed. I literally just changed the tool and changed the operation, and then give it the values for the chamfer. So it saves a lot of time now. I've had to re-input information. So from there, I will now transition back to my PowerPoint. And next operation would be the slot. So once we select slot, we have three different choices for slot. We have the longitudinal slot, which could be used maybe for like a keyway or something like that, where the radius is going to be equal to half of the width, or the end radius equal to the width, I should say. A circumferential slot. Oops, let me back up a little bit. Wrong key. Got ahead of myself a little bit there. All right, so the circumferential slot, you can, here it's showing these slots on like a circular pattern, a full circle like a bolt hole, but you can certainly select just whatever. If you just wanted to do one, you could select one. If you want to do a partial circle, you can do that as well. So again, just we're filling the values from top to bottom. We'll be using the open slot, and the open slot here shown is the spiral milling, or otherwise known as trochoidal milling. So that's the example that we'll be doing. So we'll be applying it to our part, first by selecting milling, then slot, then open slot. Fill in these values top to bottom, answer the questions, and we'll be using a half inch tool. So now transition back to SINUTrain. Go to edit, milling, go to slot. Let me bring up my part here. Okay, so we're as before, we're going to keep with the complete input mask. The cutter diameter for the slot has been pre-populated with 375. So what's important to know about these cycles, as you kind of notice, these values pop up. So it will maintain these values from the values that were in the cycle whenever you were in that cycle before that. So that means you don't have to keep re-entering. It makes editing a lot easier. It doesn't have any real default values. It just maintains the values from what they were from the time that cycle was previously accessed, and that holds true even from a different program. So 30 inches a minute, 2000 RPM, reference point. We're going to stick with the center point. And machining. Here we have an additional field for semi-finishing. So we'll have the opportunity to do that as well. But for now, we're going to be doing roughing. And with the choice of spiral milling or plunge cutting. And we will select spiral milling. And then we have the choice of a climb mill, a conventional mill, or a combination upcut, downcut. So kind of a scallop type tool path. So we will select downcut, and then this is a single position because we're just doing that one location. Center of our part in X and Y. Top of our part is Z0. And the width of the slot is 3/4 of an inch. The length, we're going to use 4 inches. We're not clocking it at an angle. And the depth of the slot, as called for on the print, is 1/4 inch. We're going to use a 35% step over. And then the DZ that's the maximum in feet depth. So by having it set at a 1/2 inch, again, as long as this value is equal or greater than this value here, it's going to take it in one pass. It's not going to come down a 1/2 inch. It's only going to come down a 1/4 inch for this slot. And then we're not going to leave any material on the finished pass. So we're going to accept that. And the next thing we're going to do with this slot is we are going to add this 2-diamond, which is the semi-finish. So what that's going to do, what the semi-finish is, it's just going to take one pass along the walls of of the slot. So that kind of cleans up the walls because of the trochoidal type milling. It's going to leave some kind of a rough finish with some bumps in there. So this is just going to take one pass along the outside to kind of clean up the edges, and everything else we're going to leave the same. So we're going to accept that. We didn't have to leave any finished stock for that. It's just going to go back and just kind of take a cleanup pass. So accept that. Go to simulation. Face milling our part, our circular pocket. Our raised boss. Finish pass. Chamfer. So here's our trochoidal milling.
So Steve, as we're watching, I see we got a question came in. Is there any way to kind of jump over or go past certain operations in simulation so we don't have to watch them every time?
Well, the way that you would do that, so whenever you start simulation, it does always automatically start from the beginning. But if you just wanted to, let's say, simulate let's say the face milling and the circular pocket, if you just go to that line in the program and put in, say, an M30, for example. So this is an example of inputting a G code directly into a conversational program. So so with that, if we go to simulation, the program's going to stop after the circular pocket. And let me speed it up a little bit more. So, and that's the end. It's done. So although you can't like start in the middle, you can start at the top and then go to and stop at any point in the program. So I hope that that answers that question.
I would think so. You know, one trick I do, and I know you probably were going to show it later, but if you put sequence numbers in, you can use go to command and jump over operations.
Yeah, good
But
point.
the problem with that is some of those operations, if they're needed, they won't be machined because you're just jumping right over them.
Right.
So just another
Right.
little trick you could do.
Yeah. Yeah. I generally put numbers in usually after I'm through editing. Though I don't use the automatic numbering sequence just because editing gets a little. I wind up having to redo it anyways. But yeah, that's a good
I
point.
agree for
Yep.
sure.
Thanks,
Cool.
Chris. All right. So we've then performed the open slot. So now we're going to get back to our PowerPoint. And we're going to start to use the drilling cycles. Minimize this. Okay, so whenever we select drilling, again, this is what we're going to be doing, the horizontal soft keys. When we select drilling, this is the vertical column of soft keys that we will see. So the choices are centering, drilling and reaming, deep hole drilling, boring, threading, and then we also have these two soft keys for where we can identify the position, either by random locations. So did you say something, Chris? Oh, I thought I heard something. I'll continue on. And then we also have the repeat position. So
Steve,
yeah,
can you hear me?
yeah, I can hear you. Did I lose you?
Hey, Danny, type in the chat window if you can hear me because I don't hear Steve.
Uh-oh.
Oh, there we go. Sorry.
I'm back.
Yep. I don't know what happened there. Might have been me.
I don't know what happened. Once in a while, I'll automatically or accidentally put myself on mute, but that didn't happen
No,
that
I
time.
think it was my side because Danny said he could hear you.
Oh, okay.
We're good. Sorry about
All right.
that. Keep going.
That's all right. All right.
Live presentations, they're always fun.
This is what makes it fun, right? Makes it more interesting. That's how you know we're doing it live. Otherwise, we would just edit that part out. Maybe in the recording you can edit it out.
Yeah, it's more fun.
I know. Just kidding. All right. So the drilling cycles. So we talked a little bit about those, and then moving along to we're going to start by centering. So we're going to use the centering function, and these are the fields that, as you can see, there's only just a handful of them that need to be entered. We'll be using a center drill, and what's referred to in the control as a center drill is actually a spot drill, right? As I learned to machine, I always would call this, what is really a combination drill, a center drill. So that was a little interesting for me at first, but anyways, that when we refer to a center drill, we are actually referring to a spot drill. All right, so we will be applying that by first select the centering, and then these are the positions that come up. So the positions can be described either by random locations, maybe a line, a array, frame, a full bolt hole, or a partial bolt hole. You also have this one for obstacles. So if you wanted to jump around some clamps and things like that, you could do that. And one thing that is new in 4.7 and 4.8, you do have the option, and it is an option in our control, is to import those locations directly from a DXF file. So these values, like this array and the frame, in version 4.5, they were still accessible. The functionality was still available. However, they would come up not as a vertical soft key, but as a drop-down menu from within the cycle itself. So with that, it's time to apply that to our part by selecting drilling, the centering, positions. And again, this is going to be on multiple planes now. So we're going to center drill all these holes on multiple planes. Transition back to Sinotrain, select drilling, centering. We have a predefined drill of a 3/8 center drill, 25 inches a minute. 1200 RPMs. Now we can define the depth of this centering function by either the diameter of the center drill or the tip, right? So in this case, I'm going to select the diameter, and the diameter I'm going to machine down to is 0.325, right? So that's how far I'm going to come down. And then I'm going to dwell for just a half a second down at the bottom, just so there's no tool marks on there, kind of smooth out that finish a little bit. So I will accept that. So now that I've described what I want to do, how am I going to do it? So the centering, and then actually I have to give the location or the positions, right? So I will select positions, and I'm going to select the random. And then this is the rectangular coordinate system as opposed to the polar. That's how I'm defining these locations. And the Z0 is actually going to be minus a half an inch, right? I'm not machining on the top of the part on these 4 outside holes, but I'm actually going to be down a half an inch. So each one of these X and Y values is a whole location. So these are the X is going to be, the first hole is going to be 2 inches, and then Y is going to be minus 1.625. So that's this whole lower right hand corner, and then the X one, and then from there I'm going to move to X minus 2. And notice I don't have to put in a Y value. I can if I want, but it's not necessary because the Y value is not changing. And then you have X minus 2, and then changing the Y value to a plus 6.25 to 1.625 to do the top, and then my final hole location in the left hand corner. So I will accept that. And then I'm going to define the next set of operations, or the next set of positions for this operation of centering. And I'm going to use the bolt hole pattern. If we look at the print, we can see that these 2 holes are actually on a 3-inch bolt hole pattern. So I'm going to select bolt hole. The Z0 for the reference point is now going to be at 0. X and Y are 0. And I'm going to clock it at 90 degrees. The first hole is going to be here, and the second hole is going to be there, as reference from 0 being our 3 o'clock position. So the radius is 1.5, and the number of holes are 2. And then I can then position move either by straight or circle. In this case, I'm going to select straight, accept that, go to simulation. There we can see our center drilled holes on multiple planes. So back to edit. I'm going to go to drilling, go back one, and select deep hole drilling. So I could be using drilling reaming, there's less fields to put in, but I'm going to do the deep hole drilling so we can do some peck drilling. Reaming, then just the difference there is it's instead of rapiding out of the hole, it feeds out of the hole. So that's really the principal difference between selecting drilling or reaming, as we can see that instead of rapiding out, there's the feed out. So cancel that. We'll go to deep hole drilling, and in deep hole drilling, you have choices of 1 or 2. We're going to be using 1, but deep hole drilling is primarily designed for gun drilling, and it just gives you a lot more versatility within that cycle. Not going to talk a lot about it today because we are kind of running a little short on time. But Chris, didn't you mention to me the other day that you're going to be having a SINUMERIK or YouTube live event coming up regarding deep hole drilling?
Absolutely, yeah. Probably not this next one, obviously, that's interpolation turning, but probably in the next month or two. That's one of those applications where you kind of gotta really see it to understand it. So yeah, keep your eyes out, keep a lookout for up and coming YouTube Live if you're interested in deep hole drilling. We're gonna show it firsthand, cutting.
All right. So we're going to be doing deep hole drilling 1, and then again complete. And the first set of holes are a random set of holes. We'll be tapping, so we're not going to use a 1/4 inch drill. We're going to use the tap drill for a 1/4 20, which is 201. Accept that. Inches per minute at 20. We have the choice chip breaking or chip removal. So chip breaking comes out by this, whatever we determine this length to be. Chip removal, the tool will come all the way out of the part. So we will select chip breaking. We're going to select with shank instead of tip. And our Z dimension is going to be 1 inch. Actually, in this event, maybe we'll just go to 0.5. Or actually, if that was an incremental dimension, if we go to absolute, maybe go to -1 inch. And then the FDI, so that's the percentage of the infeed. So it's going to feed down at 50% of the program feed rate to this location here at D1, and then we kept the amount that percentage is going to decrease. We kept that at 100, so it's going to remain consistent at 50%. V2 is that's how far it's going to come out of the hole for each of the chip breaking sequence, and then we're not going to dwell at the top, so we're going to accept that. Okay. And so for our deep hole drilling, now we have to give it the positions. So we're going to go to position repeat. And this is kind of nice because in position repeat, we just give it the position number, which is 1. I'll show you in a minute how I got that. But these are see this little asterisk there, that's where these are the 4 holes. So I'm going to accept that. And position number 1 came from this value right here, right? So that's how I selected that. And then what we also want to do at this drill is we want to tap, right? So we will select thread tapping. We're going to do a 1/4 20 tap. So there are some tables on here where you can select coarse. There isn't a table for fine threads, but we do have metric threads, Whitworth threads, and different possibilities. But we'll use coarse threads, 1/4 20, 1000 RPM. And then when we come out of the hole, we're going to go at a faster speed of 2500 RPMs. And we are not using a compensated chuck. What that means is we will be doing rigid tapping. So if you select with compensated chuck, that would be like a floating tap holder. Without compensated cut, we'll do it, just go ahead and do it in 1 cut, or we could do it in chip breaking or chip removal. We'll select 1 cut down to Z minus 1.1. We'll accept that. That's our tapping. Let me see. I actually will want to move this location to here, paste it there. So it's linked to this same location that come from.
Looks like you lost your positions though.
Yeah, right. So deep hole drilling, tapping.
Just call up the position repeat again. I think you
Yeah,
ended up
from,
copying on top of it. Yeah.
and that is number 1. Okay, so what happened there is you see these brackets here. That means that these positions are are linked to this operation. So we have the deep hole drilling, tapping at this location. So the next thing would be we're going to do another deep hole drilling. we have here? Position, circle. Change the tool to a 1/4 inch. Feed it 20 inches a minute. Chip breaking, shank, Z -1 inch. 50% will keep those values the same. We'll accept that. And then we're going to then do our milling operation, which is our counterbore pocket. We're going to use a 3/4 inch or 3/8 inch cutter. And we'll be doing it all in one pass. We'll do the helical entrance. Instead of single position, here's where we're going to tie it to the position pattern. And we're going to put in, say, a 0.5 inch diameter. Z1. So we're going to go 0.25 for our depth. Step over. Pitch, we'll keep that the same, all in one pass. Complete machining, accept that. So from there we will then go back to drilling, give it our position, repeat position, number 2, enter that. We can see we have the asterisk there, accept that, and let's give this a, let's draw it. Tapping, counterboring. Okay, there we go. So how are we doing on time, Chris? Do I have time to maybe do a little bit showing engraving real quick before we...
I'd say probably another 4 or 5 minutes, and then we could hammer into some of these questions we got.
Okay, the
For
pressure's
sure.
on. I have to do it in 4 or 5 minutes. I think I can. All right. So from there, we're going to select milling and engraving. And I'll be engraving with, in this case, center drill, and then feeding it, say 50 inches a minute in X and Y, feed down at 20, 4,000 RPM, and then we have the choice to do mirror writing or not. And then we can align the letters either straight across or on a radius. So we'll select straight across, and then of course the reference point, we have all these different selections, and we're going to select the center point. And here's where we can enter in the text. So in this case, let's just do something. Let's try this. So we're going to type in, we're going to use Siemens, and then the X0 would be the reference point, so 1.6 in X. Actually, let me change that to a negative 1.6. The Y reference point minus 2.1. Z0 minus half, because remember we're doing it on this, not the top of the part, but below. And we're going to go down 10 thousandths, and the distance between the letters, 170.175, and then, I'm sorry, that would be the height of the letters, and then the distance is 100 thousandths. We're not going to clock it at an angle. We're going to accept that. If I go to the graphic view, it kind of shows me the text box and where that's located. So if I was to change these values, that changes dynamically. So that's kind of a nice feature there too. Back to 1.6, that's where I want it. I'm going to accept that, and then I'm going to do some more engraving on the other side. So let's put something in here like we'll use the variable choice here, and then I'm going to put in the date, and then it's automatically going to take the date from the computer and load it in there. And here X, say 1.6, so just get rid of that minus sign there. Put it at the right location, keep everything else the same, accept that, go to simulation. Tapping our holes.
Look at that, right in time.
All right. So
Give us a top view so we can really see it.
okay, so there's the top view of the part. Let me turn off the
It's good. See, it
path.
always takes a second to refresh.
Yeah.
That's
Yeah.
good.
Plus, my computer's been a little slow lately. I think it has the coronavirus.
Sniffles.
Yeah, the coronavirus. I tried to actually get it tested the other day, but they told me there were no tests available. But
PCs.
yeah, I don't know who to believe anymore. But
Yeah, that's
anyways,
for sure.
I want to go back real quick to the 3D view and kind of point. You see this mark right here? So this is actually a collision. So this is an example of why it's important to have powerful 3D solid model graphics on a control. Because when I go to the top view, it looks perfect, right? But it's not. I actually have a collision there that I can easily see in the 3D view. So um, I want to point that out. Is in order to fix that real quick, what I'll do is let's just change the format to instead of 4
Make it
digits for
smaller.
the year. Yeah, make it smaller. I could move it over. That would work. But go to simulation.
So while you're doing that, why don't we start firing some questions at you? One of the questions that came in was you had showed the stock model, right?
Mhm.
Can you import a stock model?
Um, like a solid model into the
It
controller.
sounds like that, yeah.
Yeah. No, not currently. So as far as I know, there's no way to do that. Chris, do you know
So,
any differently or?
so that's correct. As far as the stock's concerned, we are limited to the primitive you see. However, if you do have a machine that's commissioned with collision avoidance or a Sinutrain machine with collision avoidance, you can import fixturing. It's a little involved. You kind of have to know a little bit about the back end, but you can get into that stuff with collision avoidance. But stock is actually fixed. So I always make the blob bigger than my overall part, understanding there might be some heavier cutting in some areas.
Excellent question. Excellent question.
Another one I got for you, and again, we're going to go through it. So anybody else has any questions as we're going, we got quite a few here. We're going to bang through, but just plug them on in. And we got a few minutes here. We can knock them out. So you mentioned software versions. Where can I see what version my machine is running? So that would be important, right?
Right. So if you select a menu select, so if you're at your machine, depending on the panel, there may or may not be a menu select key. If there's not, you just would select the upper right hand corner here. In version 4.5, it would be the upper left hand corner. So if you select this and then go to diagnostics and then go to version, there's your software version 4.8.2 on this version of Operate.
So
And
there
I
you go.
should point out also that this alarm key is also the diagnostics key. So instead of selecting a menu select, you can also select just this alarm key as well.
Exactly. And there would be the good connection back to when we were talking about downloading Sinutrain. So I would recommend, typically if we can, try to match your Sinutrain version with your machine version. That'll make sure you have optimal compatibility between the two systems. Okay. Other than content sensitive text, are there manuals available in SinuTrain? So I think that
Yes,
thing could help.
as a matter of fact, there are. So the top of the corner here, or the top of the screen in the upper left-hand corner, you see this help key. So if you select that, and then you select whatever version it is that you have. So these are the manuals that are available. So if we have like operate version 4.8, you select that. So you have some information on SINUTrain itself, what you can do with the demo machines and things like that. But in the operating manual and training instructions, if you go to that, and if you were to, you have all these manuals that are really available through SINUTrain, basic functions, universal turning, ISO millings, function manuals, everything. There's really a lot of manuals there, a lot of good information. But to give you an example of how this might look with, so if I selected this this manual for ShopMill, basically it gives me keystroke by keystroke directions on how to do certain cycles and features within SINUTrain. So it's very useful. It's a super handy thing
I don't
to
even know
have.
if I knew those manuals were up there, to be honest with you.
Yeah. There's even manuals on parameters, and there's a lot in there. It's
Of course, I usually get to them through the help as well, because if you go to the content, you can get to a lot of them as well. But that's pretty cool. You can go up there and pick them based on the version I
all
wanted.
these like compile cycles if you feel so inclined. Machine
Good
data.
luck.
Right.
All right. Another question we have. I noticed the tool list on my machine is different than what you showed. How do I get the tools to show in the carousel?
Okay, so if you select this, the offset, so this is really the tool management soft key. So if you select that, um, and then you go to this, let me move this, get this out of here. If you select this vertical soft key, the lower right hand corner, and you go to settings, you just select the graphical magazine representation. So that's a cool feature. So as you can see, you get a kind of a representation of the different types of tools, probes, face mills, different things that you have loaded based on this information that's in there. So that's how you get there. Again, is you select the offset, um, vertical soft key, and then settings, and then just check the box.
Nice, 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 nice. Um, is there a way to execute graphics one block at a time? I would assume that's probably, they're probably thinking about what we already showed with the M30, I would guess.
One block at a time, like single block.
I don't know, it says, is there a way to execute graphics one block at a time?
So one block at a time. Instead of the way that I would do that is I would go to program control and then
Yes,
single block,
that's a good point. We do have single block in there too.
right?
Yeah.
So then um, in single block, you go to simulation, right? Um, so here's the key for single block up here. So
There you
one
go.
block at a time.
One block at a time. That makes sense.
Yep.
Yeah, that's true. Because the other option would be more like one event at a time if we were blocking it with the M30. This definitely, and this you can turn on and off at will, which is kind of
Right,
nice.
right. And then just to get to the top back of the start of the program, you can press the reset. So that will go. That's a handy handy feature. You do have to remember though to turn that off. Um, so
Yeah,
once
because that'll stay on. But nice part is we do give you that little indication on the cycle start key
right.
that you're in that mode. Yeah. Okay, and then we did get a question here. Is there any way to view the G code from a ShopMill cycle or program?
So there is. So if you go to machine, let's go to bring my screen up a little bit. Go to load my program. So the first thing you have to do is you have to take this program and load it into the auto mode or the execution mode, because even though we've been editing it, that doesn't necessarily mean this is the program that it's going to run when we go to auto. So we have to make sure that we select execute. That puts us in auto. And then let's go back up to the start of the program. Okay, so you have this vertical soft key. So let's go ahead and just start it. Make sure we have our enable set, give it some juice.
There you go, you're off and running.
And then there's this vertical soft key for basic blocks. So what kind of one disadvantage of conversational programming is you're just looking at the whole cycle. You really don't know what's happening, where it's at within that cycle. But if you go to basic blocks, then it does actually show you the G code for that particular cycle. So that's a nice way to be able to see that.
We got another question came in. Are you able to hob and shop turn? So I would assume they're referring to gear hobbing. The cycle would work in shop turn. However, the hobbing cycles are custom to the OEM. So it would be up to the OEM whether or not they actually implemented the hobbing cycle in shop turn. But however, you can always call even G-code functions from shop turn. So you certainly should be able to utilize it. One of the tricks with utilizing any G-code cycles in a conversational format like Steve was showing here is in G-code, you have to do all your preparatory commands prior to getting into the cycle, right? You got to do your tool changes, fire up your spindle. So you can get to all that stuff. Steve, you want to show them where you could do like a tool change for argument's sake?
So if you wanted to, let's say, if you just pick whatever line it is in the program where you wanted to execute that, press the enter key. What's going on? So this is, of course, where my
Still running, hit reset. It's still running the program, yeah.
There we go. Hit the enter key, and then you could just like do a G0.
Or we could call the cycle per se. Yep, that could be certainly done on a G-code line. But to do a conversational tool change, expand your horizontal showcase, show them the straight circle function. Yeah. So you see that button up top, upper right-hand corner says tool. So that allows us to do tool changes without having to be in a cycle. Sets up our spindle RPM. And if you go through all of those screens, Steve had popped into one just before, there was the machine parameters as well. Pretty much everything you would need to set up proprietarily before the hobbing cycle, you could get to certainly within conversational.
I wasn't not even aware of that.
Oh, for the tool change?
Yeah.
Yeah. So yeah, you run into certain things where
a little bit, right?
Yep. Sometimes you get into scenarios where you need to do a tool change, but you can't do it inside a cycle. That's how you do it. Like say if you're going to use the straight circle commands, right, to just move the machine around. There's no tool change commands in there, so you can kind of break things down to its kind of base elements. Good. Well, let me see here. Make sure I didn't miss anybody. Oh, yep. Hold on. It says, is SinuTrain only for shop turn or can you use for running NX programs? So SinuTrain itself, we're obviously in ShopMill here in G-code, but churning or milling, either one, it will run either G-code or conversational programs. So certainly I could post an NX program, bring it in. Now the difference would be you're going to edit it in the program editor. So when Steve started the program, he said, I was going to do a new program, right? And he picked ShopMill, or you would pick shop turn on a lathe. If you do the G code, or if you had a G code file in there, it would automatically open it in this editor. Then you see the G code. All the simulation would work the same way you saw it today. You could run it in auto mode. So basically everything that Steve showed you guys from a conversational side, you can do that parallel work in G code. And actually, we've done some webinars on that topic. So I would say go to our CNC for You webinar page and check out some of the past webinars. You can certainly see it. Okay, well, I think I got everybody, but if I missed you, I will apologize now, and you can always shoot myself or Steve out Oh, we got one more popped in just before. Uh, Can SOLIDWORKS software, which has Mastercam for SOLIDWORKS from the computer, be able to run directly on the 828 also? So yes, we do support Mastercam. Now you wouldn't necessarily bring the SOLIDWORKS files into the control, but if you were designing in SOLIDWORKS, posting through Mastercam, you can certainly import those programs into an 828 and run them. Additionally, we've done a lot of work with Mastercam, collaborating with them for post development. So there's a bunch of posts that we've created. We've also done some past webinars talking about some of those Mastercam Siemens collaborated posts. So I would check out the webinar page for those as well, or shoot me an email. I can always send you guys the links out. It's a good question. Um, and
There are lots of good webinars
Lots
out
of
there.
good.
We
Another one
went to
about post processors just came in. Yeah, definitely check out our webinar page because I've done a lot of webinars about post processing. Talk about how they build, how you build them, how they interface with the control, all kinds of stuff. So check out the webinar pages, especially if you're driving your machines from a CAD CAM system like a Mastercam or an NX or one of those. Okay, well, Steve, I want to thank you for a job well done. It was a great pleasure having you join us. Hopefully, we'll be able to coax you back again real soon. And I want to thank everybody as well for taking your time out and hanging out with us here for a little while. Please, everyone, stay safe and healthy. And we hope to see everybody real soon. And feel free to reach out to us if you need us. And again, Steve, thank you very much.
Well, thank you, Chris. Thanks for the opportunity. I appreciate it, and be glad to help out in the future.
Awesome. Perfect. All right, guys, you take it easy, and we'll talk soon. Bye-bye.
Bye.